So yesterday afternoon we learned the two parent functions, the parent function for sine and the parent function for cosine. And we learned what the word amplitude means, period, and phase shift. And then we did one example where we had to draw in the parent function, state out what the transformations were, draw two complete cycles of the image function, state the amplitude, period, and phase shift, domain, and range. Okay, so we're going to continue on with questions like that. So here's our next one. Y equals cos 2 x brackets x minus 120 degrees minus 2. So first step is always to put the scale on the graph, and we're always going to use the same scale. So on the x-axis, every third square is 90 degrees. And then for the vertical scale, it's always going to be 1 squared is worth 0.5, so every 2 squares is 1. Step 1, put the scale on. Step 2, use your pencil crayon or your color to draw one cycle of the parent. So our parent is y equals cos x. And our 5 important points for cos are 0 and 1, so it starts at a maximum. And then at 90, it's at 0 out in the central axis again. At 180, it's down at -1. At 270, back at 0 again. And at 360, it's up at 1. And then from 90 to 270, it's like a smile. And then it's like you're going into 2 frowns. So from 90 back to 0, you're starting to frown. And same with 270 to 360, you're drawing it in like a frown. That's one cycle of y equals cos x. Okay? And then you look at your equation and decide, is it ready to highlight? So if there's 2 things happening with the x, is it in factored form? Yes. So I'm going to get my highlighters out. The only vertical transformation is the -2. And the horizontal are the 2 inside the brackets, the x, and the -120. And then I'm going to write out in words what each of those transformations means. Okay? So, anyone think they know what that 2 inside the brackets is with the x? Green, so yep.
Horizontal compression by factor.
Very good. Remember it all the way to the back end. Horizontal compression by a factor of a half. Good. What about the -120 degrees inside the brackets? What would be the words for that? Seth? Yes, horizontal shift, not left though. Right. Right, 120 degrees. And then in brackets, we're going to put how many squares that is. So to get how many squares it is, every square is worth 30. You're going to do 120 divided by 30, 120 divided by 30, because each square is worth 30. And that gives you 4. So right 120 is right 4 squares. Okay. And what would I call the -2 outside of the bracket at the end? Yep.
Vertical shift down to.
Vertical shift down 2. And how many squares is down 2? 4 squares. One important thing about a vertical shift or vertical displacement is it always shows you where new central axis is. And some people like that because it helps them to know whether they're moving their points correctly, because all of your 0 values should be on the new vertical axis. So our new vertical axis is down, our new horizontal axis is down 4 squares. So 1, 2, 3, 4, so it's at -2. So that should be like our new middle, -2, okay? All right, so now I'm getting my regular pencil out, because this is where I can make mistakes. And I'm going to start applying all my words here. So horizontal compression by a factor of 1/2. So I'm going to cut my distance from the y-axis in half, but 0 I'm already, 0 divided by 2 is still 0. Then I'm going to move right 4 squares, 1, 2, 3, 4, and down 4 squares, 1, 2, 3, 4. So the image of this point would be over here. Okay, so now I'm going to take my next point, horizontal compression by a factor of half. So I'm going to half my distance from the y-axis. So half of 90 is 45, which is halfway between these 2 squares here. And then from here, I'm going to move right to the 4. 1, 2, 3, 4, and down 4. 1, 2, 3, 4, and then right on my new central axis. Notice how a point I moved that was on the central axis originally is on the new central axis. Okay? Anyone have questions about how we got to any of those spots? Make sure you go through these nice and slow, because we took that time yesterday to figure out our parent functions. So today can be all about getting the right image function from the transformation. Okay, so now we're on this point here. So we want to horizontally compress it by a factor of half. So 180 divided by 2 is 90. So I'm over at 90. And then I'm going to go 4 squares to the right. 1, 2, 3, 4, and down 4 squares. 1, 2, 3, 4. So now I can move to this point, and this point. Now the 270, I'm going to half its distance to the y-axis, so 270 divided by 2 is 135, which is halfway between 90 and 180. I'm going to go 4 squares to the right, down 4 squares. And then for 360, I'm going to cut it in half, So 360 divided by 2 is 180. 4 squares to the right, 1, 2, 3, 4, down, 1, 2, 3, 4. So that should be one cycle. Okay? And it should have the same shape as the parent function. So here's my smile going into the frown. And then there should be a pattern that I can follow, because this is one cycle, but I need to draw 2 cycles. So I want to continue on this pattern to draw another cycle, but I want to know what the pattern is. So it looks like it's over 1.5 squares down 2, over 1.5 squares down 2, over 1.5 squares up 2, over 1.5 squares up 2. Okay, so it's always over 1.5 and it's either up or down 2. So from here I go over 1.5, down 2, over 1.5, down 2, over 1.5, up 2, over 1.5, up 2. Now I've got another cycle that I can draw in. And now I've drawn 2 complete cycles of the image. Y equals the cos of 2x minus 120 degrees minus 2. Okay? So now I need to do amplitude, period, and phase shift. So again, amplitude is the distance from the central axis to a maximum. So amplitude is 1. Everyone agree? 2 squares about 1, right? 1 unit on the y-axis. Period. So I want to count the number of squares it takes for one cycle, just one cycle. So that's 1, 2, 3, 4, 5, 6 squares for one cycle. So the period is 6 squares times 30 degrees for each square, which is 180 degrees. Phase shift. Use P dot S dot, so I'm going to write out phase shift. It's right in the formula. So minus 120 means right 120, right is positive, so it's just 120 degrees. So we've done amplitude, period, and phase shift. But we have to do domain and range. And we do the domain and range for just what we drew, the 2 cycles we drew. That's when you gotta just draw 2 cycles, okay? All right, so the leftmost for the domain, 30 degrees after 90, so that's 120. And then the rightmost we get is 30 degrees after 450, which is 480. And then the range is lowest to highest. So the lowest we get is -3. And the highest we ever get is -1. Okay, so you've done this one, you can start putting the scale on the next graph. Once you got your scale on, you want to identify the parent function, which is sine. And you want to draw one cycle of the parent using your pentagram. So sine is the one that starts at 0, 0. It looks like an actual water wave, which you would think of to look. So the 90 is up at 1. At 180, it's back at 0. 270, it's at -1. And 360, it's back at 0. And when you draw this, it's like a frown. And then a smile. There's your parent put on. And then your look and see if you're ready to highlight. Yes, there's only one thing with the X. So there's vertical out front, horizontal with the X. Okay? And then I'm going to write out words for each of those transformations. Highlight it. Anyone think they got word for the 2 out front? Check.
Vertical stretch by a factor of 2.
Yes. And what about the 3? That's between the sine and the X. What? Vertical compression? Horizontal compression? Not a factor of a half, but a factor of a third. Good. Okay, so remember, horizontal is the opposite of what you think, so it looks like it's multiplying x by 3 or tripling, but it's really cutting it into dividing it by 3 or multiplying, perhaps. Compressing it by a third. Compressing it by a third. So instead of being way stretched out, it's going to be way stretched in. Okay. All right, so now we get our regular pencil out, and we want to move each point. Now, notice how our central axis is going to be in the same spot because there was no vertical shift up or down. Okay. So when we move one of these points, we expect it to be back on the central axis, just in a different location. Okay. All right, so here's our first one. We want to double its distance from the x-axis and double its distance from the x-axis and third its difference. And let me start again. Yes, I'm right. Double its distance from the x-axis and put 1/3 of its distance away from the y-axis, so it's just going to stay right there. 0 times 2 is 0, 0 divided by 3 is 0. This one, double vertical stretch, puts it up at 2, Horizontal compression by a factor of a third means it's going to be a third of the distance away as this point from the y-axis. Or you can think, right now the x value is 90, I'm going to divide that by 3, a third of the distance, which gives me 30 degrees. So that means my new point is going to be there at 30 degrees and 2. So I've done 2 points so far. 180, vertical stretch by a factor of 2, I'm still on the x-axis. Horizontal compression by a factor of a third, so 180 divided by 3 is 60. And over there. Notice that 2 squares is a third of the distance of 180, which is 6 squares away from 0. Okay? Okay, so for this point here, vertical stretch by a factor of 2 puts me at -2. And then 270 divided by 3 is 90. So I'm over here. And then when I'm already on the x-axis of vertical stretch, I just stay in the same spot. 360 divided by 3 is 120, which is here. So that should give me one, like, 5. I need 5. All right, so that should give you one cycle. So let's draw it in. Oh, that wasn't very nice. Better than that. There's my skinny frown and a skinny smile. There we go. There's one cycle. And then make sure your words agree with your picture. Does it look vertically stretched compared to the red one? By a factor of 2, so doubled in height? Yes. And does it look horizontally compressed by a third? Yes. Okay, so it makes sense. Now I want to look for the pattern because I have to draw 2 cycles, and right now I just have 1 cycle. So my pattern to get from point to point is over 1, up 4, over 1, down 4, over 1, down 4, over 1, up 4. So that's an easy pattern to continue on. So now I can draw my second cycle in. And now I've drawn 2 cycles. Okay. So now I need to do, once you got your 2 cycles drawn in, amplitude, period, phase shift. And okay, then right. Amplitude, period, phase shift. Amplitude is the distance from the central axis to the maximum, so amplitude's 2. Period is the horizontal distance for 1 cycle, so we need to count squares for 1 cycle, so it's 1, 2, 3, 4. So the period is 4 times each square is worth 30 degrees, which is 120 degrees. So 1 cycle takes up 120 degrees horizontally. And phase shift you get it right from the formula. There's no plus, in the x, there's no plus 60 degrees or minus 30, there's none of that, so the phase shift we say is 0 degrees. There isn't one, instead of saying none, you say 0 degrees. Okay? And then we need to do domain and range. So domain and range just for what we drew. So the leftmost is 0 degrees. Less than or equal to x is less than or equal to the rightmost is 30 before 270. So that'd be 240. Is everybody good with that? And the range is y is an element of the reals as long as, so we're going to go lowest to highest, so -2 is less than or equal to y is less than or equal to +2. Any questions about this one? Okay. All right, do the scale for the next one. I'm just going to do the scale, yeah. So I've already got one cycle of the parent on and a different color. Parent function is y equals cos x, which is like the standing wave. So it starts at 0, 1, and at 90 it's at 0, 180 it's at -1, and 70 it's 0. And you draw it like that. Down. Check if it's ready for highlighting. It is. So I'm going to put small ones. So there's a negative. There's 1. There's a 2. There's another one. And a +3, all yellow. And then 1 green one. +1 green. So there should be 1, 2, 3, 4 transformations right now. Okay. The -1 is its own row number. 1, 2, 3, 4. And you remember what we call the negative signs? Vertical flip. What's the math word for flip?
reflection.
Reflection, yeah, good, vertical reflection. So that's the negative sign. The 2, vertical, so it is what it looks like, so it's a vertical stretch by a factor of 2. The plus 135 degrees. Horizontal shift. Left 135 degrees. And then I get my calculator out and do 135 divided by 30. Tells me how many squares that's going to be. 4.5 squares. Remember, that's the way you get that is 135 divided by 30 degrees for every square. Gives you the 4.5 squares. And then what's the plus 3 at the end? Not in the brackets with the F. Vertical shift. Vertical shift. Up 3. Which on our scale is going to be 6 squares. Okay? And the vertical shift means our central axis is moved to where a vertical shift is going to be. So our new central axis is going to be at 3. Which is a good way to know whether you've moved your points properly or not. Okay? It shall always be the same distance above the central axis as below it or on it. Okay? Alright, so then once you've done all that, you start get your pencil back out and you start applying the transformations to each point. So vertical reflection, so instead of being up 1, I'm going to be at down 1 from the x-axis. Stretch by a factor of 2, so then I'm down to -2. Then left 4.5 squares, 1, 2, 3, 4.5, and up 6, 1, 2, 3, 4, 5, 6. So that's the image of the first point. So go through all those steps. Vertical reflection, vertical stretch by a factor of 2, horizontal shift left 135 degrees, which is 4.5 squares. Vertical shift up 3, which is 6 squares. And make sure you can get this point, this image to be there. Okay? Anyone want me to go through those steps again? Yeah? All right, so I'm following the words here. So vertical reflection means instead of being 1 above, I'm going to go to 1 below. Vertical stretch by a factor of 2, now I'm going to 2 below. So now I'm here. Then it says to go left 4.5 squares, 1, 2, 3, 4.5. And then it says to go up 6 squares, 1, 2, 3, 4, 5, 6. Everybody good? Okay, you guys try to move the next one, and we'll see if we get into the same spot. It should be on your central axis somewhere. It started off on the central axis. So vertical reflection, it's going to stay where it is. Is everyone agree? Vertical stretch, it's still going to stay where it is, right on the axis. Then I'm going to move left 4.5 squares, 1, 2, 3, 4.5, and up 1, 2, 3, 4, 5, 6. So it should be right there. Okay? Pretty good? Okay, the next one. try to move the next one. So start with your vertical reflection. Hi. Did you sign the office? Or?
Yeah.
Oh, okay, perfect. Start off with your vertical reflection, then your stretch, then left, then up. So vertical reflection means instead of being one below, I'm going to be one above. Stretch by 2 means now I'm going to be 2 above. Left, 1, 2, 3, 4 and a half. Up, 1, 2, 3, 4, 5, 6. So there's my third, right here. So the 270 vertical reflection stays in the same spot, vertical stretch stays in the same spot. Left, 1, 2, 3, 4 and a half. Up, 1, 2, 3, 4, 5, 6. And then the last one, vertical reflection, down to -1, vertical stretch down to -2, left 1, 2, 3, 4 and a half, up 1, 2, 3, 4, 5, 6. So that should be your one cycle, okay? And I can see I've got a frown here. And then starting a smile, starting a smile. So there's my one cycle. Does it match all these indicators? Vertical reflection, yes, it's upside down compared to this one. Stretch vertically, yes, it takes up more room vertically than the red one did. Is it left? Yes, it's more left than the red one. And up, yes. Okay, so you can go and check that the words match the picture. That's one cycle. We need to replicate it, so we've got 2 cycles, so we have to figure out the pattern. So it looks like over 1, 2, 3. Starts at a halfway, but 3 pulls over, you're at a halfway again. So over 3 and up. 1, 2, 3, 4. Over 1, 2, 3, up 4. Over 1, 2, 3, down 4. Over 1, 2, 3, down 4. Okay, so I'm going to continue that pattern. Over 1, 2, 3, up 4. Over 1, 2, 3, up 4. Over 1, 2, 3, down 4. Over 1, 2, 3, down 4. So now I can draw in my second cycle. And then once I've done that, I've got to do amplitude, period, phase shift, domain, and range. So the amplitude, remember, it's not the number of squares, it's the distance from the central axis to the maximum. So it's from 3 up to 5, which is 2. Okay. Period. Number of squares for one cycle. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. Even though I started in halfway, okay? So period is gonna be 12 squares times 30 degrees, 360 degrees. And then phase shift is right from the equation, so it's left 135 degrees, but we call that, because of physics, negative 135 degrees. And then domain and range. So just for what you drew, so you want to figure out where does it start, the leftmost place that it starts. So that looks like halfway between negative 90 and negative 180 is negative 135. And then it goes halfway between 540 and 360. So that's 585. Did you get that? Thank you. Yeah, you too. And then the range, lowest to highest. So the lowest I go is 1, and the highest I go is 5. Okay. Yeah, all right. Okay, so do the scale for the next one and the parent. And the parent is y equals sine x. I'm going to do one cycle of that. And sine starts at 0, 0. And we put that 1. All right, then you ask yourself if it's ready to highlight. Is it ready to highlight?
Yeah.
No, this is the first one where it hasn't been, and that's because there's two things happening with the x, and it's not in factored form already. So we have to put it in factored form. Okay, otherwise we're going to think that the phase shift is left 90 degrees, but it's actually, so if you factor the b value to negative 2 out, what would you get inside the brackets? So negative 2x divided by negative 2 is x, good, and positive 90 divided by negative 2 is negative 45 degrees. So same rules hold if there's two things happening with the x. In this case there's three, but if there's two things happening with the x, it has to be in factored form. Okay? So now I'm ready to color code. So the only thing yellow is this 2 out front. And there's 3 things that are green. This negative sign, the 2, and the negative 45 degrees. And that makes 4 transformations I should be listing here. 4. Does anyone have one of them? One of the 4 transformations? So. Okay, I'm going to put that one last. 2, 3. Horizontal shift. Now you can't just say by 45. You have to say which direction which it is. Did you? You said it right. Right? Right. Right, 45 degrees, and then we also want to know how many squares that is. So if I do 45 divided by 30, I get 1.5 squares. Taking the time to do this really helps you get the right graph and also reflect back and make sure that you got the right graph. Okay? Who's got another of the 4 transformations? Jack.
Horizontal reflections.
Horizontal reflections. I'm going to put that one here. Another one? Molly?
Horizontal compression by a factor of half.
Yes. Horizontal compression by a factor of half. And? Molly?
Vertical shift by a factor of 2.
Close vertical stretch, because we're multiplying. Stretch by a factor of 2. So shift is up or down, stretch is when you're actually making it further from the central axis. So because there isn't a vertical shift, do I move my central axis anywhere? No. It's still going to be right on the x-axis. Okay, so there's 4 things I have to think about when I start moving. So I get my pencil out. Start with this point, vertical stretch by a factor of 2, I'm still in the same spot. Horizontal reflection, I'm still in the same spot because of 0, 0. Horizontal compression, I'm still in the same spot. Horizontal shift to right 45 degrees, I can actually do that. So there's the image of my first point. Okay, 90, vertical stretch by a factor of 2, so I'm up at 2. Horizontal reflection, so instead of being at positive 90, I'm over at negative 90. Horizontal compression by a factor of a half, so instead of being at negative 90, I'm at negative 45, which is here, halfway between 0 and negative 90. And then horizontal shift right 45 degrees, so that puts me right up here at 0 and 2.
Yeah.
We're going to go through that one again?
No, I just heard one.
Yep, okay, so starting here, so vertical stretch by a factor of 2 puts me up to here.
Yeah.
Horizontal reflection, so instead of being 90 degrees to this side, I'm 90 degrees to this side, so I'm over here right now. Then I'm going to half that distance from, so my horizontal compression, instead of being at negative 90, I'm going to be at negative 45, which is here. And then I'm going to move 45 degrees to the right, so that's a square and a half, which puts me there. Okay? The 180. Vertical stretch doesn't affect it because I'm on 0. Horizontal reflection, I'm going to go over to negative 180. Then I'm going to half that horizontal compression. So instead of being at negative 180, I'm going to be at negative 90. And then I'm going to move 45 degrees, so a square and a half to the right. So there's my third point. So I can see I've got a frown there. 270. So vertical stretch by factor of 2. Horizontal reflection. Uh-oh, there's no negative 270 over here. What am I going to do? Okay, so good, Jacob. Jacob says half it because he knows that I'm going to have to half it after. Okay, horizontal compression, so that's great. So what's half of negative 270? Negative 135, which is halfway between negative 90 and 180. So here I am, and then a square and a half to the right. Okay, so again, I'll do that one again. So vertical stretch puts me here. Then my horizontal reflection puts me way over at negative 270, which isn't on my graph. But then I know I'm having it. So I divide negative 270 by 2, and it tells me I would really be at negative 135 after I've done both of these. And negative 135 is halfway between negative 90 and negative 180. And then I'm doing my horizontal shift right, 1 square and a half, which puts me here. Okay, that's good thinking, like that. And then 360, the vertical stretch doesn't affect it. Horizontal reflection, so again, I'm going to be over at negative 360, which isn't there, but then I'm going to divide by 2, which puts me at negative 180. And then I move a square and a half to the right. So now I should have one complete cycle there. Okay. So I'm going to draw in my cycle. So I have a frown here. And a smile here. And I'm going to look at my words and see if it looks proper. Is it vertically stretched by a factor of 2? Yes. So it takes up twice as much space as the red one vertically. Is it horizontally reflected? Yes. So it's going that way instead of that way. Okay. Horizontal compression by a factor of a half, so it takes up less space in wideness as the red one does, half as much. Horizontal shift to the right 45. Yes, that one's harder to tell from the graph, but we did do it. Okay. Now I want to make sure I've got a consistent pattern and draw in another cycle. So my pattern seems to be over 1.5 down 4, over 1.5 up 4, over 1.5 up 4, over 1.5 down 4. So I would go over 1.5 down 4, over 1.5 up 4, over 1.5 up 4, over 1.5 down 4. To draw my second cycle in. Oops. So now I've got 2 cycles. Now I have to do amplitude, period, phase shift, domain, and range. Amplitude, period, phase shift, domain, and range. Okay, so my amplitude is 2. And the period is 1, 2, 3, 4, 5, 6 squares. So period is 6 squares times 30 degrees, which is 180 degrees. So how many squares is it for one cycle? So 1, 2, 3, 4, 5, 6. Yep, for one complete cycle. And this one's for 30. And then the phase shift is right from the backward form of the equation. So right 45 means positive 45 degrees. Remember, for phase shift, right when you're writing it down is positive, and if you wrote the word left, you would write it as negative. And then domain and range for what you drew. This is the domain leftmost. So figure out where that. Let's start that. So halfway between negative 90 and negative 180, or a square and a half back from negative 90 is negative 135. And then we end up at halfway between 180 and 270, which is 225. And then for our range, lowest is negative 2. Highest is 2. Okay, so that's the idea, that there's lots of practice so that you get good at it. So if you're given a function in this form, some good things to know without graphing it, you can tell what the amplitude is. The amplitude is connected to the A value. We say it's the absolute value of A because it can never be negative. If you remember way back when we did absolute value, it was the absolute value of negative 2 is positive 2. Okay, so if A happens to have a negative sign in front of it, just ignore it. But let's look back at our pictures and see if the amplitude always turns out to be the A value. So the A value is 2, the amplitude was 2. The A value was 2, the amplitude was 2. The A value was 1, the amplitude was 1. The A value is 2, the amplitude was 2. Okay, so you can see you can always tell the amplitude from the A value. The period, this is a really good formula, is always 360 divided by the B value. So here's B right here. It helps you find the period without drawing out the picture. Okay? So if you take 360 and divide by whatever the B value is, that should always turn out to be the period. So get your calculator out and let's try it out. So here the B value is just a 1, so it should be 360 the period, and it was. Here the B value, ignore the negative sign, it's a 2. So 360 divided by 2 is 180, and let's see what we got for period. 180. Okay? And then here the B value is 2 again, so we should have got 180 for the period, and we did. Here the B value is 3, so 360 divided by 3 is 120, and we did get 120 for the period. Okay? So that's how the B value can help you get the period without drawing the picture. And also B has another meaning. It's the number of cycles that fit into 360. So if B is 3 cycles can fit into 360 degrees. Okay, if B was 2 cycles can fit in 360 degrees. If B was a half, only a half of a cycle can fit in 360 degrees. The phase shift is h degrees. The vertical displacement is k, and the central axis is always moved there. Okay, we've already talked about that. But this one's interesting. the maximum value can be found by adding the amplitude and the vertical displacement. So we have this cool formula for the maximum value. It's always k plus the amplitude. Maximum value means the highest step it's ever going to get. Okay, so let's look back. K plus the amplitude. So for me, the maximum value, k is 3 plus the amplitude, which is 2, because the amplitude is never negative. So the maximum should be 5. Look, the maximum is 5. Okay. Here, maximum is the k value, which is 0, plus the amplitude, which is 2. So the maximum should be 2, and it was. For this one, the maximum should be the k value, which is -2, plus the amplitude, which is 1. So it should be -1, and the highest it ever gets is -1. Okay? And then for C, the k value, there's no k value, so sorry, the maximum is the k value, which is 0, plus the amplitude, which is 2. So the maximum should be 2, and it is. Okay, so that's a formula for getting the maximum. And then, analogously, the minimum is k minus the amplitude. The minimum is k minus the amplitude. So let's try that out. Minimum here would be the k value, which is 3, minus the amplitude, which is 2. So the minimum should be 1, and it is. Minimum here, the k value, which is 0, minus the amplitude, which is 2. So the minimum should be -2. It is. Here, the minimum is the k value, which is -2, minus the a value, which is 1. So the minimum should be -3, which it is. Okay? So that formula you can use as well. And that's going to help us, all those things are going to help us be able to complete a chart or a table like this without drawing any of the graphs. Okay? So we're going to do the amplitude column first. So just by looking at the equation, remember amplitude is the absolute value of the A value, which is the number up front, meaning that it can never be negative, never negative. So who thinks they know the amplitude for the first one? 2. Darius, you just want to go all the way down?
3.
Yep.
1.
Yep.
2.
Yep.
5.
Yep.
4.
Good. So ignore the negative. Every number out front. Remember there's a 1 there, not a 0. So that's the amplitude. Period. Remember you have to use that formula. Period equals 360 degrees divided by the B value. So I'm just going to highlight the B values. So here it's 1. I should use the skinnier one. There's a 1 there for B, 2 for B, 3 for B, a half for B, 3 for B, and a third for B. So you just get your calculator out. 360 divided by 1 is 360 degrees. $360 divided by 2, 180 degrees. 360 divided by 3, 120 degrees. Remember that's how much it takes horizontally for one cycle. 360 divided by a half, 720 degrees. It takes 720 degrees for just one cycle. 360 divided by 3 is 120. 360 divided by a third means multiply by their reciprocal, so times 3 is 1080 for one cycle. That's horizontally stretched by a factor of 3. Okay. Phase shift. So this one the words we would say would be right 135 degrees, which means positive 135 degrees in phase shift words. This one, we'd get tricked and write negative 240, but it's not in factored form. So you have to factor the 2 out, and it should be negative 120 degrees. Okay? The third one would be 0 degrees, because you're not moving it left or right at all. And same with the fourth one. Not moving it left or right. The next one, again, you could get tricked and say negative 180, but it's not in factored form. So you have to divide 180 by 3. So it's really negative 60 degrees is your shift. Left 60. And the last one's already in factored form, so the phase shift is left 60, so negative 60 degrees. Maximum value, remember, is K plus A. So 1, this is my K, plus 2 is 3 would be my maximum. Here K is 0, plus 3 is 3. Negative 5 plus 1, negative 5 plus 1 is negative 4 would be your maximum. Okay. Careful with this one as well, it's 3 plus 2, because the amplitude's never negative, so 5 would be your maximum. Negative 4 plus 5 is 1 would be your maximum. And negative 1 plus 4 is 3 would be your maximum. And for the range, we know that we can do this part of it. These are our maximums. But we need to know all our minimums in order to complete it. And remember, our minimum is K minus A. And your range is always your minimum to your maximum. So my K value is 1, minus A is 1 minus 2 is negative 1, so that should be my range, negative 1 to 3. Zero is my K, 0 minus 3 is negative 3, so my range should be negative 3 to 3. Negative 5 minus 1, so K minus A, negative 5 minus 1 is negative 6, so my range should be negative 6 to negative 4. Always make sure that the number you start out with in the range is smaller than the one you end up with. Okay? Or you can make a mistake in your thinking sometimes. Here would be 3 minus 2, which is 1. That's not right. Oh, here's the 1. That's why I just put it in the wrong spot. It is right. 1 to 5. Negative 4 minus 5 is negative 9 to 1. And negative 1 minus 4 is negative 5. And then the last page is just success criteria, which has a bunch of reminders for a step-by-step you can go through to find the image function from the parrots.